This is how to wire a VFD, a variable frequency drive, the beginner-safe way. Three-phase supply into a breaker, out to the drive, then U, V, W across to the motor, and a handful of control wires for run, stop, and speed. It looks like a lot. It is really just two halves, power and control. Let me show you both, then draw one live. So what is a VFD actually for? One job, controlling the speed of a three-phase motor. A plain motor wired straight to the mains runs at one fixed speed, full stop. A VFD sits in between, and it rebuilds the power the motor sees. Here is the trick. It takes your fixed 50 or 60 Hz supply, turns it into DC, then switches that DC back out as an adjustable frequency. Change the frequency, and the motor changes speed. The drive raises the voltage in step with it, so the motor keeps its torque. That buys you three things. A soft start, so the motor ramps up instead of slamming to full speed. Fine speed control, for a pump or a fan or a conveyor. And real energy saving, because slowing a fan down uses far less power than throttling it. That is the whole point of the box. Now, let us wire it. One quick note before we go on. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. Start with the power side because it is the part that moves the motor. Power comes in on the top of the drive. Three input terminals labeled L1, L2, and L3. Some brands mark them R, S, and T. That is your three-phase supply, and it lands there through an input breaker or a set of fuses. Smaller drives can also take single phase in on two of those terminals. Then the output on the bottom. Three more terminals, U, V, and W. Sometimes T1, T2, T3. These go straight out to the three-phase motor and nothing else. So the flow is simple. Breaker in a L1, L2, L3. Drive does its work. U, V, W out to the motor. And one terminal you never skip, the ground, marked PE. The drive gets earthed, and the motor gets earthed, both back to that point. Use shielded cable on the motor run, too, because a VFD is electrically noisy and the shield keeps that noise off everything nearby. Now the single rule that saves drives. Write it on the enclosure. Never put a contactor or a switch on the output, the U, V, W wires, and open it while the drive runs. Breaking a spinning motor off at the output can blow the drive transistors in an instant. If you must isolate the motor, stop the drive first from its control terminals. And a mirror image mistake, just as fatal. Never feed mains into the output. Input is L1, L2, L3. Output is U, V, W. Cross those two, and the drive is gone the moment you power up. One safety word, and it matters. This is three-phase mains. And a VFD holds a charged DC bus inside for minutes after you switch off. The capacitors stay live. Wait for it to discharge, and leave the work to a qualified person. With the power side safe, the control side is where you tell the drive what to do. These are the small terminals, and they run on low voltage. Digital inputs come first. You assign one to run, one to stop, and often one each for forward and reverse. Two ways to wire them. Two-wire control, where a single maintained switch means run or stop. Or three-wire control, with separate momentary start and stop buttons, like a real motor starter. Next, the speed reference. This is an analog input, and it is how the drive knows how fast to go. A potentiometer wired across, it gives you a dial, 0 to 10 volts, or a 4 to 20 milliamp signal from a controller. Turn the pot, and the motor speeds up and down. Then the outputs. The drive has relay contacts that report back. One for running, one for a fault. So a panel lamp or a PLC can see what the drive is doing. Two more you will meet. Braking resistor terminals, for dumping energy when a load slows the motor down. And the motor nameplate settings, voltage, current, frequency, and rated speed, typed into the drive once, so it protects the motor correctly. Enough theory. Here is a real one. Open straight in the editor. You can see everything we just covered on a single sheet. Supply and breaker on the left. The drive in the middle, power in on top, motor out of the bottom. The control terminals off to the side, with the run contacts and the speed pot. Follow any wire from end to end. That is what a clean drawing gives you. Now, let us draw a small one from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A breaker for the incoming feed. A box standing in for the drive. A load standing in for the motor. And a ground. These come from the free do-it-yourself pack the guest editor gives you. The dedicated VFD and motor symbols live on the paid tier. But these shapes are enough to lay out the idea. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. The drawing never turns into spaghetti. And here is something a plain drawing tool cannot do. Simulate it. I will open a ready-made control template, a direct online motor starter, the hardwired cousin of the drive. There's a real spice engine inside the page. Hit Simulate, choose the DC operating point, and run it. Live voltages and currents land right on the wires. If a connection were wrong, the numbers would tell you before a single wire got crimped. That is a check no paper drawing can give you. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a work order or a group chat with whoever is doing the install. Vector formats, PDF and SVG and DXF sit on the paid plans. That is the honest business model, and I will say it plainly, this tool is ours. For clean control and schematic drawings you can share and mark up, it is genuinely good and free to start. One last thing, because a VFD rarely runs alone. Out in the world, a PLC usually gives the drive its run and speed commands. If you want to build and run that motor control logic itself, our sister PLC simulator does exactly that, and it is linked in the description. Draw the wiring here. Run the logic there. So that is a VFD, start to finish. Powering on L1, L2, L3. Motor out on you, VW. Never a contactor on that output, and never mains into it. Ground both ends, shield the motor cable, then wire run, stop, and a speed pot on the control side. Open the free editor and lay out your own drive, a breaker, the drive, a motor, a ground. It is at CircuitDiagramMaker.app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.